All right, let's try this again. So, example 4, we are talking about using a table and finding the table values. The best thing that I'm going to say here is I feel like if you're starting at -2, you want to see basically how many 5s you have to add on to get to that value that you can see. Does that make sense? So if I'm at h equals -2, this would be the same thing as h of -2 plus 5, because that's one cycle. And if I do h of -2 plus 5, that leads me to a value that is on the table. Does that make sense? So that value on the table is h of 3. And what is the output at h of 3? 0. So my answer is 0. Do y'all see the pattern that went through my head now?
Yeah.
Okay. It was there, though. We were there. Okay, h of 6. H of 6 is in between something here, but I can't add 5 because that'll take me off my table. Does that make sense? So h of 6, I'm going to do what? Subtract. So I'm at 6, and I'm going to subtract 1. I'm going to subtract 5, and that's going to put me at 1. So its equivalent value is going to be h of 1, which is -2. So again, essentially, I just see it as a puzzle, okay? Now, this one is a composition. So we have to first figure out what h of 9 is. Does that make sense? So we're going to do h of 9. H of 9 is off my table, right? So in order to do that, I'm going to have to do what? Subtract. So for h of 9, we're replacing it with 9 minus 5. And 9 minus 5 is 4. So h of 4 equals what? Equals 3. So now we're substituting that in, and we're now actually looking for h of 3. H of 3 equals 0. So our final output is 0. Okay. Okay. So it's saying here, if we have 5k minus 3, where k is an integer, no matter what is going to be its the k value? What is it's going to be the output every single time? So in order to do this, we have to think about it in parts. So the first thing we have to think about is the -3 plus 5k. We're just going to reword it to see which one of what we've been doing does it compare to. Does that make sense? So we have h of -3 plus 5k. I just rewrote the 5k minus 3. Remember, subtracting a negative is the same thing. Subtracting a positive is the same thing as adding a negative. Okay, so here, -3 plus 5k is very similar to what we did on A, right? We took our value and we added 5 to see how many times it would repeat. Yes? Okay, so because it's at -3, that means whatever the value at -3 is, because we're adding on from -3, that's going to be the value of every output from that pattern. Does that make sense? So if I'm at -3 and I'm continually going -3 over and over and over, just plus 5, plus 5, plus 5 from -3, that's what that value is. Does that make sense? So essentially, we're looking for whatever h of -3 is. Yes, I can. So explaining it again. So you remember we rewrote this 5k minus 3, correct? Okay, when I rewrote it, it fit the format of our example A, correct? Where we had our input plus our period. Yes? But in example A, we only went one cycle ahead. Make sense? But what if I had to keep going continuously, right? That's a multiple of that period length. So it's k cycles, the k number of cycles. So here, my starting point is -3 plus 5, which is our periods, a number of cycles in that period. Does that make sense?
So what you're saying is that 5k cancels because it's at the period.
5k, exactly, because it's going to be this value every single time because I'm just repeating it over and over and over.
So if we get that, it's going to give us like k times the number of
whatever the length of the period
is. So if the period's 3, it'll be 3k.
It will be 3k. Okay. So it'll be the length of your period.
It just cancels.
It's canceling, but it's just letting you know that this is a repeated cycle. It's a period.
Right.
Right? So This 5K is just letting you know on and on and on, right? What you're really focused on is what is h of -3. Does that make sense? That's our real focus to figure out what this would be. Okay? So our real focus is h of -3. So if I need h of -3, I'm going to use which method? The first one, right? So I'm going to use h of -3, but however, does that get me back into my table? No, it doesn't. What? Well, does it? Yeah, 4. I can add. Can you add? Sometimes.
5, 7,
There.
Yeah.
Exactly. Good job. You're a genius. All right. So when I look here, I can do 7, right? I can keep going. I can add. I either can subtract from 7, which is what August sees it as, or I can add to -3. Does it matter which way you do it? It does not. Okay. So if you chose to do what Hudson said, he went backwards. He went to 7 and he subtracted 5 twice, right? Or you can go to not Hudson, sorry, August. Or you can go to -3 and add 5 twice until you get to a value that's on the table. I'm sorry. Okay. So here in this case, I'm going to model both and you can choose whichever one. So you can do -3 plus 5 times 2. Or you can do 7 minus 5 times 2. Does it matter which one you do? No, but the value here, this one is telling you that you're starting off at your answer, and your answer is 2. This is you're starting. This one is telling you that you're going to end at your answer. Does that make sense? You're going to end, and either way, it's still going to be 2. It's just how you visualize the period pattern yourself. So whereas I like to work to the right, August said he likes to work backwards, like with the subtraction, which is all the same. Did we not come to the same conclusion? Yes, we did. Okay. Okay. So this section is really about just recognizing patterns and being able to follow through with the pattern based on the length of the period and the given information. Okay. And the same goes whether it's in table form or in graph form. You're identifying a starting point and using the given information. Okay. They're never going to give you the value you're looking for on your graph or your table. All right. Got it? All right. So let's tie it together. So in this case, you either, for example, when people ask, most times people are subtracting versus adding from what you have to see if you can get to the value, especially if it's smaller. So on x minus 5, so for 7, we did 7 minus 5 once, still didn't get us to -3. Then we did -5 again, and it got us to our -3, right? So we knew that -3 had the same value as 7, okay? All you're essentially doing is translating, because that's all a period is, a periodic model is just a translation of that same function that however length the period is, right? So all you're doing is translating. There's a limited number. There's a limited output based on the graph that's given. Okay. So here we have our last period example that we're going to look at. Well, before we get to more trig stuff, the graph F is a periodic with a domain of all real numbers. 2 full periods of F are shown. Find all input values of F that yield an output value of 1. Okay. When they're asking you for an output of the same value, that means you're writing it with a K variable, because it's saying if this pattern continue, where would it keep going, right? What all values would have this? So we're looking for an output value of 1. So if we're looking for an output value of 1, we get an output value of 1 at 2 and 6. Correct? That's when we get an output value of 1. Your output value is your Y, right? Your Y. What is your Y? So there's 2 things you need to identify here. Is 1, where does it begin? That's a highlighter, not a pen. So where do we begin? So where do I first get my output value of 1? At x equals 2. And then how long till it comes again? Until it repeats. And it's at 4, right? So our period equals 4. Does that make sense? These are the two things you need. Once you have these two things, you now can make a statement of when this happens. So the period is 4, and we will get an output at when x equals 2 plus 4 k times. And k is an integer. Does that make sense? So the first thing we identified is where does it begin? The second thing was how long until it repeats.
So then the 2 would be, so 2 would start the equation.
So 2 is where I get my first output of 1, right? And then every 4 units, I get another output of 1. And then every 4 units, I'm going to get another output 1. And then every 4 units, I keep getting an output of 1. Yeah? How do we feel about being able to write where the pattern continues? 2 simple steps. Where did you begin? And how long did it take for you to get that value again? Yeah. Like what's the periodic? How long will it take for your output? Remember when we're talking about output, we're looking at our Y's. Yeah. We just did example 4. Where were you at? Yeah, right here.
Oh. What question?
Did we not do example 4? Y'all have 2?
Oh, it says in example.
It was summarizing. Yeah, this was the summarizing. In example 4, we can come up with, yeah. All right. Okay, our last part is now talking about how does this come together? I do not want to read this entire thing, so we're going to do a little popcorn reading. I'll read a sentence and then pop on to somebody else. Got it?
I think we did 5.
No, we just did 5.
We just did 5.
But that was-
We just did 5.
When it says in example 4, it's like a summary.
Yeah. All right, so we have here, the figure shows a large clock mounted to a vertical wall. Pop.
The clock has 8 inches long, has an 8-inch long moving minute hand.
Next.
Center of the clock is 120 inches directly above the floor.
Okay.
Yeah, Thank you.
August, you want to read? You and Hudson, since you're talking?
What about Michael Jackson?
We're reading a problem out loud as a class.
Michael Jackson, which sentence do you want?
We're at time.
At time equals 0 minute. The minute hand is pointed directly up at the 12. However, choose someone. Lana.
However, the clock is not working properly and the minute hand is moving twice as fast as it should.
Thus, the next time the minute hand points directly up to the 12 is that time, taking 30 minutes.
Oh, Abigail, you've been called upon. Go, Abigail. All right. So there's a lot of important information here, right? That we need to highlight and mark the text and apply to our picture. So starting off with, we know that the clock has, let me not have a red one. The clock has an 8-inch long moving minute hand. So 8-inch long moving minute hand, which in sense is its almost radius, right? The center of the clock is 120 inches directly above the floor. At t equals 0 minutes, the minute hand is pointed directly up at 12. However, the clock is not working properly and the minute hand is moving twice as fast as it should. Thus, the next time the minute hand points directly up at 12 is in 30 minutes instead of in 60 minutes. Does that make sense? Okay. All right. So looking at our picture here, things that we can start off by noting is that this is 120 inches, right? And this little guy is 8 inches. So at its highest point, how high is from the ground, the very tip? 128 inches. So our highest points have to be what? 128. Does that make sense? So we know looking at this graph and analyzing the time that our highest 2 points have to be at 128. F and P. I wrote 128. Okay. So with that in mind, what would be our lowest? 120. So J would be 120. Yes.
Oh,
Mm-mm. 6 is the number, but it's not in inches. We're writing what the output would be. And at 6, we would be how far from the ground? It's from the ground. So it's saying measuring the center, right? Like at the very bottom, not including the inch hand, this would be just 120. So when it's at 6, it's at 120. Yeah.
Wait, hang on.
Okay. So then where am I at? Or where are we at? G and K. Oh, I see what Emiliano was saying. It's 112. I knew that. I was making sure you knew that. It's at the bottom. You saw nothing. Because it's the bottom here. And this whole thing is 120, which means that this is 8. So this has to be the very bottom, has to be 112, which is what Emiliano was saying.
So you're saying that the top is actually off.
Oh, is the bottom of the clock?
Yeah.
120.
This whole thing. So
No, I'm saying from the very bottom to the top of the clock.
from the center to the ground, it says it's 120 inches. So from the center of the clock, this is 120. No, from to the top, this is only 8 inches, which is why our highest is 128. Okay.
Saying from here to here, it's 136, right?
No, it's 128.
Why is it?
Wait, how does that make
8
sense?
and 8 is 16. Plus
Because this is already including the 8. This is it's from the center of the clock to the ground is 120. So this 8 is already accounted for in that 120.
Oh.
Yeah? Does that make sense? So like Emiliano said, this has to be our minimum, but our minimum will be 120 minus 8, which makes it 112, right? Our center is 120, and then our max is 128.
I
That makes
understand
sense.
now.
Yes?
Like you change the things to say 112 because that's the. Oh, you're saying up to the I got
Yeah,
it. I
right
got
here.
it.
Yeah. All right. So now this is where I want y'all to figure out. So we're gonna I'm gonna stop teaching, and you're now gonna figure out what are your inputs. So what is the time for each one of these? Okay, meaning in minutes, where am I at? So in terms of minutes, where am I at on the clock? Okay. So if I'm at 12, this is 0 minutes, right? So then I go do, 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 and then boom. Now, remember, this clock is moving how fast? Twice as fast. So it's not just 0, then 5. It's 0, 10, do, 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 and it's coming back around to 30 because it only takes 30 minutes for this clock to make its full rotation. So what your task is, I'm going to give you about 2 minutes to figure out what are the outputs, I mean the inputs. So we found our outputs. What are my inputs for all 5 points? Mhm. Yes, you do start at 0 because that's 0 minutes, right?
So wait, point F is 0?
Yes. All right, go. All right, so as y'all were talking, Randy brought up a good point. Our full cycle, that's our period, and it takes us 30 minutes, right? For this broken clock to go, it takes 30 minutes. So obviously, this one is starting at 0, and this one has to end at 30. Does that make sense?
Oh. Wait, I already did.
Yeah. Okay. Then halfway between these two would be what? 15. So halfway would be 15.
Why did you say I did?
And then halfway between those would be what? There we go. So between 0 and 15, we're at 7.5. And then halfway between 15 and 30, we're at
22.
there we go. And those would be our points.
What did it say?
Let me see if I can write it prettier for you. So we have F 0, 128. We have G. G is at 7.5, comma 120. We have J. And J is at 15, comma 112. We have K, and K is at 22.5, comma 120. And we have P, which is at 30, comma 128. So every 30 minutes, we know from these 5 points where that clock, how far that hand would be from the ground. Does that make sense?
No idea exactly. No idea. Oh, that's feasible.
Okay. Maybe I can answer your question afterwards. Maybe you just need to talk it out. Yeah. So the next question says, referring to the graph at H part in A, the t coordinates of G and T1, the t coordinates of, we already did them. Oh, on the interval, which of the following is true about H? H is positive ending. Which one's true? What do we get?
I thought it was J. Wait, what are we looking at? Wait, which part is this supposed to refer to?
On the interval, it says J. So looking
J.
on the interval J, which of the
Okay.
following is true about H? So just from,
Oh,
yeah, just from G to J.
I think it's C.
So we got, it's D.
D?
Mhm.
Why did they D?
But isn't it fixing to ink?
It says from G to J.
From G to J?
It says the coordinate, looking at the coordinate G is your T1 and the coordinate J is your T2. On that interval, what is it doing? Huh?
I thought that's concave up.
It's concaved up. Oh, sorry, positive and decreasing. Did we say B?
I said C.
How are y'all saying?
Negative, it's going down.
It's concaved up. It's multiple choice. The graph is what?
Decreasing.
The graph is decreasing, but the concavity is what? So it's B.
But isn't it?
The concavity is doing what? Up. That's what makes it positive. Your rate of change is positive. So when you're describing positive and negative, you're analyzing the concavity. Yes? No? So if we're concaved up, that's gonna be positive, correct? Concave down is gonna be
Negative.
a negative rate of change. The next part is how is your function changing? Is your function increasing or decreasing? And on this interval, what is the function doing? Decreasing, but it is concave up.
It's like an increasing, wasn't it? Because now it's fixing the curve.
That's why we said it's positive, but the function is decreasing. The rate is positive because the rate is that's how you show that.
Let's say they're asking from F to G, is that, negative
I thought
and increasing,
I was
negative and
confident in my
decreasing?
answer.
Was it the piercing?
This is negative and decreasing.
That's negative and decreasing, okay.
The
You're
piercing.
concave down, and the function is decreasing. Yes? All right, describe how the rate of change is changing over the interval, and that's how we would describe it. So the rate of change is
Increase.
increasing because the function is what? Concave up. That's the word. Because it's concave up. We're gonna need to make a concavity something to help us remember concavity. Huh? Yeah.
I remember it being flipped on the piercing assignments. That's why I thought it was.
Was it?
Yes, I remember.
It could be me.
I
I'll double check.
remember it was supposed to be like decreasing and it's going at an increasing rate, so it's fixing the start increasing. That's how I remember it. Maybe I got it wrong.
Okay. It'll,
The assignment